Okay, the topic of today is positive externalities and the Coase theorem. You may not know what that is. You're going to learn by the end of this lecture. So let's get started. All right, what we did last time in class was we talked about a negative externality. That's a consumption or production activity which spills over and has a negative effect upon other people in the country, in the society, in the community. And the classic example of that is pollution. But here we're going to be talking about positive externalities. What if the production of something spills over and has a positive benefit on other people elsewhere who were not directly participating in that particular action? And we can think now of the global climate change issue and say, well, what about something like wind turbines? Now, wind turbines are going to create power only in a particular local area. But by virtue of not burning fossil fuels, it's also going to have the small consequential effect of reducing carbon emissions and could be a kind of a solution or a step in the direction of a solution for global climate change, which thereby, if it can reduce the amount of carbon dioxide and slow down global climate change, it's going to have a positive benefit for people in the future. So there's an example of a positive externality. By switching to alternative energy sources that are non-carbon based, we could solve this externality, this negative effect, by promoting these positive changes instead. Okay, so how can we do that? First thing to take note of is if there's a positive overall effect from using wind turbines, if we just let the private market operate on its own, we're going to end up with an underproduction of that particular good. So let's consider the market for wind turbines on the left-hand side. Let's imagine it's competitive, and the private price and quantity that would arise is where the standard supply and demand curve for wind turbine energy appears. Okay, again, we'll just put it in our simple context of a market. Now, second point, let's suppose that the production of wind turbines causes these positive external effects by reducing carbon emissions. Okay, what we're going to do now is we're going to change the position of the demand function, if you will, and create a new function that's called the social benefit function. Now, the social benefit here is going to be equal to the private benefits, which is really just the demand curve, okay, plus the externality benefit. And here, in order to get this right, we would have to be able to measure the positive spillover effects that are likely to occur as more and more wind turbines are used. Not an easy thing to do, but we're going to just assume we can do it. We're going to plug it in, and we're going to see how that affects the policy that could be used to correct for it. Okay, now, just as we did with the negative externality, we're going to imagine that the vertical distance between the social benefit curve, this SB here, and the demand curve, D, which is the private benefit, the vertical distance right here corresponds to the positive benefit per unit of wind turbines that are produced, okay? And, you know, I've got a big jump here in social benefit. Maybe it would be a much smaller jump, but the direction of change is all we really need to account for here. All right, so what does that imply? Well, when we intersect the social benefit curve, which is measuring both the private benefits and the externality effect itself together, the intersection of that with the private cost curve, which is the supply function in the market, is going to determine the socially optimal level of output of this particular product. And we can see from that Q social is greater than Q private. And that means if we leave the private free market on its own, the decisions are going to result in an underproduction. Q PVT is less than Q social. And we're going to see in just a minute, that's going to reduce overall economic efficiency because we're not taking into account this spillover effect that's taking place in the economy. So let's see how we correct for it. Okay, the government can achieve the social optimum by using a subsidy, okay? And we know that by using a subsidy, we can actually stimulate the production of a particular good and push it out in the direction that we want to push it in this particular case. Now, in order to achieve the quantity Q social, we need to generate a price for producers that's higher up here, and we need to generate a price for consumers off of the demand curve that's lower. And a subsidy set equal to the difference in those particular prices is going to be able to achieve exactly that effect. All right, so that's the subsidy rate that's needed in order to generate the socially optimal level of production, which is Q social. All right, now if we do that, consumer price is going to fall, of course, and demand is going to go up. Producer price is going to rise, and supply is going to go up. That means supply is going up along here to get to this higher producer price. Demand is going up along this demand curve with a lower price to consumers. And so consumers and producers are both going to be willing to produce and consume more with the deviation in prices that arises on production and consumption. All right, now let's calculate the welfare effects. Here are the welfare effects first. We're going to focus on the externality effect first before looking at the effect of the subsidy. Okay, and the first thing is we're going to look at the externality before the subsidy is implemented. Okay, and again, we want to note that the distance between here and here at the quantity QPVT represents the per unit benefit that's being generated outside of the market. And we want to take that and multiply it by the quantity that's actually being produced, which is this distance right here. So we could take this distance, the red line that I've just drawn, and multiply it by this distance, the distance between these two dots, and that would give us the total benefits that's accruing to others outside of the market. But here I'm going to do something a little bit different. I'm going to note that that vertical distance here is actually the same as this vertical distance right there, because we imagine this demand curve is shifted up. This distance is the same everywhere, this red line. Same here, same everywhere. So if I move it over to this distance right there, then I can take right here this distance and multiply it by this length, which is QPVT, and I'm going to get an externality effect before the tax equal to plus A plus B plus D plus E. Okay, so it's this area right here. Again, that vertical distance is being determined by looking at that distance right there, but just carrying it over to QPVT, and that's going to map out our area A, B, D, and E. Okay, now, if we were to measure the total benefits to the market overall with the externality in place at the private market outcome, we're going to get this much consumer surplus, this much producer surplus, and we're going to get this much additional benefit accruing to people in the other markets because of the positive spillover effects of the externality. So we're going to take this triangular area, producer and consumer surplus, and add A, B, D, and E to it again in order to get the total benefits accruing to the market in the presence of this positive externality effect. All right, now, what are the externality effects after we put the subsidy into place? In this case, the subsidy is going to stimulate production out to Q social. And as a result, the total spillover effects is going to increase to this entire area here. All right, and it's going to be given by a plus again, A plus B plus C now, plus D plus E plus G. And as a result, the change in externality effects, we got A's before, both there, the B's are there before, the C is new, the D's are there, same as before, and we've got a plus E plus G. So this is the change in the externality effect that's coming about because of the stimulation of production. Oh, I got it wrong. Okay, so we got E up here, we've got an E there, so the E doesn't show up here, and F shows up there. Let me clean it up to make it better. So the change in externality effect, A, B, C, D, E, F, G, and so the change in externality effect is going to be a plus C plus F plus G. The F is what's new. Okay? Basically, we're adding on. By stimulating production, we get an extra benefit that's going to accrue to society overall given by area C, G, and F. All right, now, let's talk about all the effects together. We calculated the change in externality effect, which I'm going to add here at the start. It's plus C plus F plus G. We got that from the previous slide. Now let's go back and just calculate, again, the welfare effects of putting the subsidy into place. Okay, the subsidy is going to, again, stimulate production out to this level, split the prices apart, to PP and PC respectively. So the change in consumer surplus, consumers originally were getting this area here, but now they're actually getting this bigger area here. So the consumers are getting an additional benefit equal to area plus D plus E plus F. Consumers are better off because they get a lower price for this particular good. If you subsidize wind turbines, electricity is going to be cheaper and consumers are going to be better off. Subsidize solar panels, consumers are going to buy more solar panels because it's cheaper and they're going to be better off as a result of that. Producers. Well, producers are getting subsidized here directly with the subsidy. Their producer surplus originally was given by this area here, D and below it, but now it's going to be given by this larger area, adding on area plus A plus B plus C. This is exactly the same welfare effects we were doing some weeks ago when we were just talking about the natural effects of a subsidy in a particular market. Now, the change in government revenue. The taxpayers have to pay for this particular subsidy, and the total amount of the subsidy payments are going to be given by the distance here, which is the subsidy per unit, times the number of units that are actually being produced, which is this distance right there. So we're going to have to subtract off A plus B plus C plus D plus E plus F plus G. And that's the subsidy payments that have to be collected from taxpayers in order to make this program work. All right, what's the net effect? Let's add these up. What we're going to end up with is the DEF here matches with the DEF here, and they cancel out. The ABCs on the second line cancel with the ABC on the next line. So A's cancel, the B's cancel, the C's cancel. Now, we've got a minus G here and a plus G. So the minus G is going to cancel with the plus G, and we're going to be left with just C and F. So the total effect after all is said and done is going to be a positive C plus F. That means market welfare has gone up automatically with the subsidy. It means that economic efficiency is improved. And it also means that the market was inefficient, not doing as well as it could before the tax was implemented. Okay, the subsidy is actually improving the overall economic outcome in this particular market because it's taking account of the positive external effect that's being caused in others outside of the market. All right, so summary here. Although the subsidy causes a deadweight loss, you'll remember that we highlighted this particular area here as what's going to be left over as a cost to just the subsidy alone. And that's the deadweight losses that are accruing as a result of the subsidy. But the deadweight losses are going to be outweighed by the benefits they're going to accrue, and the benefits are given by this whole area here. Okay, so the benefits are the red area. The costs, because of the subsidy, is given by the yellow area, G, and we're left with the positive net effect given by C plus F. Now, I'll point out one other thing. C plus F happens to be the same. This area F is the same as this area up here by geometrical construction. So when we talk about the benefits that are arising in the economy, we're actually getting this area right here is the sum total benefit that's going to accrue to the economy because of the subsidy in the presence of the positive externality. Okay, because C plus F is the same as that green area on the diagram. All right, and so, conclusion, government subsidy can raise economic efficiency when it corrects for a positive externality, and the free market outcome, the private outcome here, is inefficient. It's not the best we can do. Leaving the free market to its own devices is not going to give us the best economic outcome that's possible. Government intervention can actually do good here. It's actually going to improve the overall well-being of people in the market overall, while causing some benefits and losses to people along the way.